This videotape will show you how to use and read some of the common precision measuring tools found in the machine shop. A machinist must work to close tolerance. Therefore, it is necessary to be able to properly use and accurately read the precision tools of the trade. The instruments covered in this videotape include the outside micrometer, depth micrometer, inside micrometer, telescoping gauge, hole gauge, and spring calipers. After viewing this tape, you will be able to write down the safety procedures used in the machine shop, identify parts and uses of the micrometer and other measuring tools, accurately read these instruments, and properly handle and care for these instruments. When you are in the machine shop, you need to protect yourself from hazards around you. Always wear your safety glasses. Remove rings, watches, and other such jewelry. Roll your sleeves above the elbow. And a clean working environment is always a safer working environment. So clean up oil spills in the floor and place refuse in proper containers. The outside micrometer, sometimes referred to as a mic, is used to measure outside diameters and thicknesses of materials or parts. It comes in many forms and sizes, ranging from a 0 to 1 inch measuring capacity up. The different types are inside, outside, and depth. Some of the more common forms of micrometers are the standard with flat anvil and spindle, the blade for measuring grooves, the needle point for measuring narrow shapes, the screw thread for measuring thread pitch diameter, the disc for measuring slot to edge, and the ball attachment for measuring tubing walls. Although micrometers come in a wide range of sizes to accommodate different dimensions, they can only operate over a 1 inch distance. For example, you would use a 1 to 2 inch micrometer to measure dimensions of greater than 1 inch, but less than 2 inches. Similarly, you would use a 5 to 6 inch micrometer to measure dimensions of greater than 5 inches, but less than 6 inches. The 5 main parts of the micrometer are the frame, the anvil, the spindle, the barrel or sleeve, and the thimble. Options which you might find on some micrometers are the ratchet stop and the lock nut. The micrometer operates on a simple principle of using screw threads to read measurements directly and accurately. The threads on the spindle are designed to move the spindle exactly 1 inch when the thimble has made 40 complete revolutions. That is, each complete revolution of the thimble moves the spindle exactly 1/40th of an inch. By converting this fraction to a decimal, 1 revolution of the thimble moves the spindle 25/1000th inch. You will see an index line on the sleeve of the micrometer with numbers above the index line and 4 minor divisions between each number below the index line. The numbers mark off a major division. It takes 4 revolutions of the thimble to move the spindle 1 major division. Since 1 revolution of the thimble moves the spindle 25/1000ths, or 1 minor division, and 4 revolutions of the spindle 1 major division, a major division is therefore equal to 4 times 25/1000ths, or 100,000ths. On the edge of the thimble, there are 25 divisions, which are equally spaced and numbered from 0 to 24. Since 1 revolution of the thimble moves the spindle 1 minor division, or 25/1000ths, then each division on the thimble measures 1/25th of 25/1000ths, or 1/1000th. For you to read a dimension on a micrometer, you must look at 2 places, on the sleeve and on the thimble. The major division on the sleeve will give you the first number after the decimal point. The second and third numbers after the decimal are reached by adding the minor division reading on the sleeve and the thimble division reading. For our example, we are using a 0 to 1 inch micrometer. The major division reading is 2, the first number after the decimal point, or 200 thousandths. The minor division reading is 2 lines past the major division. Since each minor division line is equal to 25 thousandths, 2 times 25 thousandths equals 50 thousandths, and our thimble division reading is 17. 17 times 100 thousandths equals 17 thousandths, for a total reading of 267 thousandths. As you can see, the micrometer can be used to provide readings which are accurate to the third decimal place or to the thousandth of an inch. Now practice by reading these 0 to 1 inch micrometers. What does this micrometer read? The major division reading is 6, or 600 thousandths. The minor division reading is 1 line past the major division line, or 25 thousandths. And the thimble division reading is 12, or 12 thousandths. 600 thousandths plus 25 thousandths plus 12 thousandths equals a reading of 637 thousandths. Now try another. Read this micrometer. You should have read 750 thousandths. That's a major division reading of 7, or 700 thousandths, plus 2 minor division lines, or 50 thousandths, and 0 on the thimble, which totals 750 thousandths. Now read this micrometer. You should have read 496 thousandths. As we mentioned before, a micrometer can only operate over a 1 inch distance. Therefore, if a workpiece measuring between 2 and 3 inches is to be measured, a 2 to 3 inch micrometer would be used. The micrometer would then be read 2 inches plus the major and minor readings on the sleeve plus the thimble readings. Or, as in this example, 2 inches plus 400 thousandths plus 25 thousandths plus 17 thousandths for a micrometer reading of 2 inches, 442 thousandths. Some micrometers are equipped with a vernier scale, which allows a reading to the 4th decimal place, or to a 10,000th part of an inch. The vernier scale consists of 10 lines parallel to the index line on the sleeve. To read the vernier scale on a vernier micrometer, first read to the nearest thousandths. Then find the line on the vernier scale that lines up with a graduation on the thimble. The value read on the vernier scale line is the value in 10 thousandths. For example, this vernier micrometer reads slightly more than 237 thousandths. The line numbered 3 lines up with a graduation on the thimble. This gives us a reading of 3 10,000ths, or a total reading of 237 thousandths and 3 tenths. Now for practice, read this vernier scale. You should have read this vernier scale at 6, or 6 10,000ths. This is the proper way to hold an outside micrometer when making measurements on small pieces which can be held in the left hand. From this position, you can rotate the thimble until the workpiece is clamped lightly between the spindle and the anvil. Be careful not to exert too much pressure, as this will give an erroneous reading and could also damage the micrometer. A micrometer with a ratchet stop allows you to exert a safe and consistent spindle pressure on the work. Whenever a predetermined amount of pressure is reached, the ratchet stop slips and prevents further tightening. Some machinists prefer to use a feel in making measurements with a micrometer instead of using a ratchet stop. This feel will develop with experience. When you are measuring outside diameters, it is important that you hold the micrometer squarely across the diameter to get a true reading. To get long and useful life out of your micrometer, you should take the following precautions. Wipe it down with an oily cloth after use, and occasionally add a drop of light oil on the screw to keep it operating smoothly. Check for accuracy by closing the spindle gently and noting if the zero markings on the thimble and spindle line up. If the zero markings do not line up, adjust the micrometer according to the manufacturer's instructions. If you have to open or close the micrometer a great distance, roll the thimble on the palm of your hand. And, if possible, store the micrometer in a box of its own, and always store measuring tools separate from other hand tools. The depth micrometer, or the micrometer depth gauge, operates on the same principle as the outside micrometer. This instrument is used for measuring the depth of holes or shoulders. You can increase the measuring capacity of the instrument by using extension rods of different precision lengths. Changing rods is a simple process of unscrewing the cap, inserting the precision rod, and replacing the cap. Notice on this instrument that the major divisions marked on the barrel read from right to left, or opposite the outside micrometer. As you rotate the thimble in a clockwise direction, the rod is extended. To properly use the micrometer depth gauge, you must first insert the extension rod of the proper length. Next, place the gauge firmly over the shoulder or hole and extend the rod by turning the thimble. When the rod touches the bottom, take the micrometer reading and add on the length of the rod. When taking the micrometer reading, remember that the major division you wish to record is covered by the thimble and is not the exposed numbers. The micrometer depth gauge requires the same care and maintenance as the outside micrometer to provide long and accurate service. Inside micrometers are used to measure inside dimensions. They are equipped with extension rods for measuring dimensions of 1.5 inches and up. Inside micrometers are equipped with the same graduations as the outside micrometer and are read in the same manner to the nearest thousandth of an inch. Inside micrometers should be stored in their own case for protection and to guarantee their accuracy. The telescoping gauge is a helper-type measuring instrument which has no dimensions on it and has to be used with an outside micrometer. It is used to determine internal dimensions. This T-shaped instrument has two contact points. One of the points is spring-loaded and capable of telescoping within the other. The lock on the handle allows you to lock the contact points in any position from fully extended to fully compressed. Telescoping gauges usually come in a set. These range in a measuring capacity from 1/2 of an inch to 6 inches. To make an internal measurement, select the appropriate gauge for the size of the measurement, compress the contacts, and lock them. Insert them in the space to be measured and release the contacts. When you have a proper fitting, lock the contacts in position. Remove the gauge and make a reading with the outside micrometer. The hole gauge is another helper-type measuring instrument that is not calibrated and has to be used with an outside micrometer. It is mostly used for measuring openings which are too small to use with a telescoping gauge. Hole gauges usually come in a set and have a measuring range from 1/8 inch to 1/2 inch. The instrument has two contacts which can be moved in or out by turning the knurled handle. To measure with this instrument, you select the appropriate gauge, close the contacts, insert it in the hole, expand the contacts to proper fitting by turning the knurled handle, then remove the gauge and make the measurement over the contacts with an outside micrometer. Spring calipers are also considered helper-type measuring instruments because they are not direct reading and have to be used with a rule, micrometer, or vernier caliper to determine the size of the dimension. Calipers are designed in basically two varieties: the outside calipers and the inside calipers. Spring calipers are generally used where less precision measurements are required. When you use the outside caliper to measure the dimension of round stock, you should be careful that both legs of the caliper are lightly touching the stock across the center line. You can then make a direct reading of the dimension by holding the calipers to a steel rule like this, or by using an inside micrometer. Inside calipers, as the name implies, are used for making internal measurements. You can make a direct reading of inside dimensions by holding the calipers to a steel rule like this, or by using an outside micrometer. Let's review what you've seen in this videotape. The outside micrometer is a direct reading instrument that can measure to 1/10,000th of an inch. The inside micrometer and depth micrometer are direct reading measuring instruments which measure to an accuracy of 1/1000th of an inch. Telescoping gauges, hole gauges, and spring calipers are helper-type measuring tools which must be used along with other direct reading instruments. All of these instruments should be handled carefully if you expect them to retain their accuracy over a long period of time. The machinist works with very precise measurements, so the better you master the techniques of using these measuring instruments, the better machinist you can become.